All right. Thank you for the nice introduction. My presentation just load in a second. So my first question to you would be, what does this piece of code do? I will give you a couple of seconds to think about it. It's not very difficult, but still useful to give some thought. All right. If you're brave enough, you can shout it. You're not brave enough, that's also fine. I'm just going to tell you then. So it goes to an API, it fetches some information about dogs, and then it tries to get more information about dogs, right? So let's try to run this piece of code. Yeah. So how's your day going? Is it good? I'm really enjoying this conference. So yeah, let's give a huge applause to all the organizers. And in the meantime, I have received all the things that I really needed. So I have a bunch of URLs here, and let's just check one of them to make sure that everything is working. Yeah, so this is a picture of a beautiful Shiba Inu. Shout out to the maintainers of the dog API, by the way. They're really going to make this talk work. My next question is, what does this piece of code do? Yeah, it looks like the same thing, right? The structure feels the same, the URLs look the same. Let's run it real fast and let's see how it performs. Whoops, let me just go back. Oh, I spoiled the game. That's fine. Let's run the async code. Whoa, that was fast, right? At least much faster because I couldn't fit an applause in this part. Okay, so hi everyone, my name is Ákos Hochrein, and in the past year I've had the chance to work with fully asynchronous backend systems with Asyncio. And I know it's still a controversial topic in the Python community, but I want to give you some ideas and some tools on how to get started with the entire thing, and maybe give you some help in getting started. So let's start with the basics, all right? Let's just go through this part again. So I would like to teach you a couple of things about the basics of Asyncio to help you grasp the context of how how Python works. And the core of it is going to be the event loop. So what is the event loop? It's basically a task execution system that's going to receive multiple methods from us, and then it's going to figure out how to execute these methods in the most optimal order possible. What does this mean? It basically means that when these two functions arrive, the first one is going to be picked up in order by the event loop, and then it's going to be executed. Does some stuff, math, reading a book, I don't know. And then it gets to an I/O operation. It gets to something that we know that's going to take time, so we can just let it work on the side, and we can focus on other things. So we give back control to the execution system. And then the execution system goes to the other function and says, hey, you haven't started yet. Let me just give you some space. So it starts executing it, and then we hit another I/O operation. All right. So in this case, this function is going to give back the control. We're going to go back to the first one, and then that one finishes its operations, all the I/O, all the network, all the writing to the disk, all the writing to databases. All of that is done, and we just get rid of it, essentially. And then we do that with the second function as well. And what's really cool about this system is that you can really just start piling up your asynchronous methods into them, and then there's going to be a task queue that's going to be maintained by the event loop, and you don't need to worry about the execution whatsoever in the future. So it sounds quite basic, right? And I want to give you the basic building blocks in Python with which you can achieve this. The first one is going to be the coroutines, the second one futures, and the third one are going to be tasks. So what are coroutines? Did anyone ever work with generators before? Good number of hands. Good news to you. Coroutines are basically generators, all right? So they have a point in their function where they give back control, and then you can just pause the execution of the function itself. So my question to you is this code going to be synchronous or asynchronous? There are no good or bad answers, so if you have a feeling, you can just throw it in. That's the correct answer. This code is, as a matter of fact, right now going to be synchronous, meaning that first the print docs function is going to get called, and then in order, the Labrador, the Golden Retriever, and the Pug is going to be printed after sleeping for a little bit of time. We can also check it out, if I can find my terminal. Yeah. So let's just say Python coroutine.py. Yeah, this is not going to be super exciting. As you can see, it exactly works like a regular Python code would. Cool. So let's move on to futures. Who has dabbled in JavaScript here before? Good number of hands. OK, so I'm a full stack developer by default, so I write a lot of JavaScript. So if you're familiar with JavaScript, futures are basically very, very similar to promises. OK, so you basically say, hey, I want something to be done in the future, and then something should happen after this is finished. By definition, from the Python documentation, futures encapsulate the asynchronous execution on a callable. This is probably the most unsexy thing that anyone has said on stage today and yesterday on this conference. So I'm just going to make it cool and simple, and I'm just going to say callbacks. So we have callbacks in Python with the power of futures. And I would like to give you a short demo on how they actually work. Can you read this code from the back as well? I kind of checked, and my eyes are horrible. Some people are nodding, so I'm going to just go on. So this is basically the same code as you have seen there on the slides. What it's going to do is it's going to create a couple of future objects according to what we pass into it. Again, the Labrador, the Golden Retriever, and the Pug. It's going to execute some simulated I/O, and then we're going to set the result of the future to the breed that we have. And what's really cool is that in this case, what we can say in line 22 is we can just say future.add done callback, and then we just press, let's say, the print done. And then we add another callback, and that's going to be the print result. Cool. So let's run this code. Hopefully it's going to work. Yeah. So as you can see, now asynchronously, I have attached functions to the finishing of another function or a future object, essentially. And this way I can execute things in the future as much as I want. What's the issue with this right now? Yeah, the done has executed before. That's not a huge problem in this case. The future, the callbacks get executed in order. What's an issue is that my script didn't stop. Everything is still hanging because the event loop did not realize that it has to stop, right? So this is kind of a problem that we're going to have to solve in the future because we don't necessarily always want to have millions of things running in our background, right? So I'm just going to kill this. Bam, huge exception. Let's go. So futures are cool, but what's even cooler are tasks. So let's circulate back to the original example that we had. So I think this code is not the best example here. I just realized it like 6 minutes before the talk. I'm going to fix it afterwards. But essentially, what tasks do is that they take coroutines. And when the coroutines are waiting for a future-like object, that's the point when they're going to give back control to the event loop, so the event loop can optimize the execution of our functions. So basically, tasks are what really make the async I/O and the event loop fast, This is how you can execute code in parallel in Python without using threads. So this is a lot of information, and it's pretty difficult to process. It took me months, and I just gave it to you in 10 minutes. So if this is a lot, then I have some recommendations to you to check out. There is David Beasley's talk, Python Concurrency from the ground up. This is not about Asyncio, but it's a lot about generators, and it's a lot about, oh, here's a QR code if you just want to scan it. So I highly recommend checking out this talk if you have any interest in continuing exploring this area. Good job, everyone. We deserve a banana because we got through the difficult part of the talk. So yeah, let's move on to some more exciting stuff. So how does this entire thing look in production, and what are the tools that you can go and start working with immediately? The first one I would like to mention is AIO HTTP, which I would say Asyncio on the web. AIO HTTP has two main modules. The first one is going to be the AIO HTTP client. This is the client that's going to allow you to execute get, put, post, whatever requests you want to do towards various web services in an asynchronous manner that's going to be non-blocking in your event loop. So these are just two functions I'm using throughout the demo, actually, or the demos. It's quite simple. The first one takes a JSON response, and the second one takes a text response. What's a little bit more exciting is the AIO HTTP server. So basically, with the power of the event loop, we can say that we write fully asynchronous backend services in the way that, for example, we don't need GUnicorn in the future. I mean, we do need GUnicorn because it provides us with a lot of other things, but with the AIO HTTP server, we don't really need to rely on it anymore. What's cool about it is that if you are anyone familiar with Flask, everyone's familiar with Flask, absolutely amazing. It's got a very Flask-like interface, so it's quite easy to write new handlers. And yeah, so I just wanted to show you that we will have a short demo here as well. I just need to open AIO HTTP server, and I'm going to write. So why is this good? Why is this better than Flask? And I want to demo it to you in a very short way. I'm going to create a new handler, handle fast. Let's just call it that. It's going to take a request, and I'm going to return a web.response, which is the standard response in AIO HTTP. And I'm just going to say that the response text is, this is fast, yo. Perfect. And I will also set up a route for it. So web.get, we will say that this is the speed test endpoint, and we're going to use the handle fast handler. Cool. So I created a new handler for this. It's quite easy to understand. And let's try to run it. It's going to be AIO HTTP server.py. Perfect. So, by the way, what this does is, it just goes and fetches dogs by default. But we can also quickly check out the speed test endpoint. And yeah, it responds with, this is quite small, right? Let me help you. So it responds with what we have typed there, but this is not very special so far. So what's going to be really interesting in this case is that I'm going to run a quick benchmark on it with the Apache benchmark tool, and let's see the response. So here, what you can see is that we are able to execute, in this moment, 2,700 requests on this endpoint. It doesn't do much, but you can already see that it can take a lot of load, actually. Let's shift back to the presentation. Just to indicate this in a couple of graphs. So This data indicates the speed up compared to Flask. You can see that AIO HTTP is like 3 times faster without anything in a regular compared to a regular Flask application. And if you add gunicorn and more workers, then it gets even faster and faster. This data is not mine, I have to say, but it comes from a blog post by Dean Sheff. It's a very good blog post. If you are not convinced about the speed capabilities of AIO HTTP web, you should definitely read this and check it out for yourself. All right, so now that we are done with the AIO HTTP on the web, or Asyncio on the web, I want to mention another package that's called AIO jobs, which I would call Asyncio in the background. With these, you can create these future-like objects out of the box in Asyncio with this keyword that we call spawn. So with spawn, you can just say, hey, I want the background task to be executed, and essentially, you will get a queuing system by default that works like a charm. I have a demo for this as well. I will just need to kill my server here. And I think I call it AIO job server. Oh, perfect. So I have a syntax error here. So we will fix that really fast. Yeah, I was editing this code right before the talk. This is what you get, Ákos, for doing that. Perfect. All right. So if you come back here, now this should be working. Yeah. So basically what this code does, I also pulled in a little bit of other stuff here. You can see that when we call the endpoint, what I want to do is I want to fetch the information from the dog API, and I want to save the URL into a separate file. With this, I wanted to simulate some I/O for you in this case. Yeah, so it went to fetch the Labrador, and it went to save the Labrador as well. We can check my file system, and yeah, you can see that the Labrador.txt is already there. Let's just make this a little bit bigger. I want to make this a little bit more prominent, though, because you can say that writing a file is not a very difficult thing to do. So I'm also going to simulate a little bit of I/O here. I'm just going to await a sleep of, let's say, 10 seconds. So basically, what you would expect here maybe is that our request is going to hang for 10 seconds, and then the files are going to be written, right? Right? Well, it might be surprising, or might not. Let me clean this up. Let's run the server again, and let's go to the website, and let's search for a Puggle. Yes. Wow, I got a response immediately. And in the meantime, if we look in my folder, the Puggle is not there, and I need to talk for a couple of more seconds. And the Puggle already exists. We can also, check out what's the content of it, and yeah, perfect. All right. So we got this nice Puggle as well, and you can see that I could have written the file, but I didn't want to crash my computer. I could have written, terabytes of files here. It would have been all executed in the background with an immediate 50 millisecond response to the front end. Brilliant. Really fast. There's an issue with it, though, right? I mean, we all kind of feel that this is sketchy, right? So what do you think is the real problem is with this? Yeah, so essentially we don't know right now if it's successful or not, right? So if we figured it out or not. And this leads to another issue actually, is that everything runs in memory. So everything that you do is stored in your memory. If you create too many tasks, then the task queue gets full, and then everything gets into cold memory as well. And this could lead to a lot of issues, one of them being that if there is a server fault, then you will lose all the tasks that you have queued up. So by itself, AIO jobs is insanely powerful, but you will need other sort of tooling that's probably handwritten by you to support it. Another tool to make things a little bit faster is AIO cache. I'm not going to demo this one because it's very, very straightforward. You can just import the cache module, and then you can define a time to live cache. You can define caches by size, but it's very easy to use with a decorator. So in this example, what you can see is I use the afetch function as I wrote as a helper, and then I put a decorator on it to make it cached, and it's a 10-second cache. So for 10 seconds, it's going to return the same photo of the puggle if we don't want to DDoS the dog API during this talk all the way. What's really cool about it is it also supports multiple backends. So there's Redis, Memcached, and in-memory cache is currently supported. And yeah, they're looking for people to build even more modules for it. So this is a lot of stuff. You can go and browse around in github.com/aiolibs. And here you can really find most of the well-supported Asyncio tools that you can be using for making your applications faster and async compatible. I gotta say that kudos to the entire community around this. There's a lot of work put into this already, and it's getting much, much more popular than it was a couple of years ago. So good job. All right, let's look at this turkey now. So I wanted to talk about a couple of difficult things that are going to come up once you decide that asynchronous computation in Python is going to be the way you go. The first one being testing. I know every one of you was thinking, oh my God, but how am I going to test this code, right? That's what I always think when I see some sort of new tool. Well, it's hard as nuts, I gotta say. But things are getting better. So testing asynchronous code is, as I said, not the easiest, but tooling around it is getting much better. So if you are using PyTest, the PyTest Asyncio module has a bunch of decorators that you can use to mark your asynchronous tests and essentially make it seamless and make it seem like synchronous in the future. And the async test module itself is going to provide you with mocking functionalities for coroutines, because sometimes you will need to mock your coroutines, your futures, all these things in order to be able to test them well. Yeah, let's talk about a couple of iffy stuff that still might come up and will come up during the time when you are working. Once you go async, you gotta go full async. There is no other way to do it today. This basically means that unless you want to fiddle with futures, unless you want to do that, you will have to use libraries that are Asyncio compatible. And for example, if you are using an exotic protocol, it's very possible that no one has ever written that before for Asyncio, and you will have to implement it yourself or ditch the entire project and shift back. The other part is that basically nothing is thread safe. So this is a big issue, and it's highlighted almost everywhere in the Python documentation itself. So if you want to make sure that the things you are working in memory, in your caches, in your databases are fine, you will either have to use modules that already support thread safety, or you will have to manually do stuff with shielding your coroutines, with doing all sorts of magic. So if you are doing that, then probably this is going to be a difficult write for you. But there are good news as well, of course. So let's look at the outlook a little bit to the future. The first two things I want to mention are Fast API and Starlet. So async AIO HTTP web is, super low level at this point. But there are two API projects, Fast API and Starlet, that are essentially working on building frameworks like Django, for Django-like frameworks that are going to make our lives easier. Fast API is a more backend API-related thing. It works. It has built-in Swagger support, for example, and so it generates all the documentation for you. And Starlet is more of a web framework where you have templating by default. It supports Jinja, and of course, both of them are fully asynchronous. Another project that you might want to keep your eye on is HTTPX. the wonderful team in Edinburgh called Encode is working on this project today, and they're trying to redefine how Python is going to interact with the web. They have a preliminary asynchronous client already on the go. This is an alpha project, so probably not ready for your production services, but it's still, I think, a good thing to follow. All right, we're getting close to the end of the talk. And I wanted to give a couple of shout-outs to people I've been working with for a year. I'm with Bruno and Omar. They are my great friends, and without them, this talk wouldn't have been possible, and me knowing stuff about asynchronous computation wouldn't have been possible. We built multiple backend systems together with this tooling, and yeah, I just wanted to thank them for all of this. This is my face, this is my name, and I'm a technical lead manager at Prezi in Berlin. As many companies here, we are also hiring to 4 cities actually. So if you liked the tone of my voice or something like this, want to hear it more, then you can come up to me and we can chat about the technologies that we use. Prezi is, by the way, a visual communication company. This is one of the products that we have that you have seen here. You can find me on various places on the internet. I have a GitHub, I have a blog that is mirrored to Medium, and I also have a Twitter. And I also wrote a book this year. It's going to be published in December. I know there's a lot of things that I'm mentioning here about myself. I'm a web developer, so I wrote a book about microservices. If you want to talk about microservices, I'm also very open to do that. And yeah, thank you very much. The slides are going to be available on this website. You can also scan it with your QR code. This is a GitHub repo. All the examples that I ran today, I'm going to fix them, are going to be here as well. So yeah, and I'm open for questions. Thank you.
Thank you. So we have quite some time for questions.
Hey, super nice talk.
Thank you.
Lars Jenkin from LiveSum. So we've started shipping a first Asyncio service, and one thing that we notice is that someone can add a piece that's blocking, like, oh, they add a new, add some new instrumentation, and then all of the nice stuff kind of comes to a halt very quickly. I'm wondering if you've got any ideas how you could catch that, not just in review, but like in CI or somewhere more automatic?
Yeah, so that's a good point, and this is one thing that we actually faced as well. Like some of us, pulled in libraries that we really wanted to use, and then we noticed a significant drop in performance in our service. So what I can recommend in this case is to have monitoring for your backend APIs, and probably when you see that the requests per second that you are serving is dropping, that was the point when a package that was not intended to be used asynchronously has been pulled into your system and deployed. This is the best idea I can give, and also do pull request reviews.
Okay, more questions. Don't worry, lunch will be served for a long time.
Hi.
Hey.
What are the main things about Python that makes it hard to implement this universally in some way, so that you can pull in anything you like and have it run in a separate thread or process or things like that? Is there anything stopping that from being realized? So we wouldn't have to worry about whether we can find the tools we want to use implemented in a specific way?
I will try to understand the question first. Thread programming is difficult. I just had lunch yesterday with Henrik and Simon, and Henrik mentioned that there's a photo in the Mozilla offices that says that you have to be this tall to write threaded code. So I think Asyncio is one of the things that relieves this. So because when you are running Asyncio code, you're always running everything in your Python process. I didn't have time to showcase this here, but the CPU intensity actually grows like crazy when you're running asynchronous code. So the first time when we were running the dog API example, it used 12% CPU mean. And the second time we ran it with the asynchronous code, it used 68% CPU mean. So yeah, it actually does a lot of work and a lot of the thinking that you don't need to do when you are running threaded code. And I think what's difficult about getting started and just touching the libraries themselves is I myself am a web developer. So for me, working with very low-level protocols, file-level protocols, sockets, stuff like this, it's not my daily job, and it's not something I'm very adept in. So this is why I think it's difficult to get started with it and to find the right tools to work with.
Right. If I wanted to make something asynchronously compatible with things like this, is there like a toolbox I could use to, chunk up things and do a little at a time and then let other things happen in the,
Yeah, it's a great question. So Asyncio has socket support by default. So you can just go and read all the Asyncio documentation around this, and then you can implement your own Asyncio libraries that are compatible with the web, that are compatible with, I don't know, sock.js or Thrift or gRPC. Asyncio supports this on the very, very low level, but you have to put your layers around it.
Okay. Are there good tools to run like a series or parallel thing like you have, for instance, with promises in JavaScript? There's like a toolbox built in.
Yeah. So the other one that could be used is the Concurrency Module that's also built into Python. And it basically has most of the things I was talking about here. That runs things in separate threads. So things can get a little bit whacked there on the operation system level. But yeah, if I were using another tool, then I would use either that, or there are actually multiple implementations of the event loop on Python today as well. But the drawback of those implementations is sometimes all the libraries have to be re-implemented to support that event loop. So there's an event loop that's really, really well designed called Trio, but Trio has no AIO HTTP web support, for example. So the tooling around it is not there yet.
Okay, so we will take one more question. People with food, I kindly ask you to keep the noise level.
You mentioned there was an issue with thread safety. Could you expand a bit on that?
Yeah, so basically thread safety means that when you are trying to access certain parts of your memory with the different processes, it could be jumbled, right? So the same issue that we have with threads, we have here in Asyncio as well. You do need to implement locking. You do need to implement tools to make sure that you don't override values that you want to override in your memory, or on a disk, or in a database, or stuff like this. So these are not built in by default. Does this answer your question? Kinda. You can find me afterwards.
Yeah, I guess we have a warm and welcoming atmosphere, and you can discuss behind the scenes. Thank you very much.
Thank you.
Thank you very much for coming.